I want to talk today about AI agents. I know that was mentioned quite a bit in the previous panel, so maybe not quite a bit, but I was afraid they would steal my thunder, but I think I'm good. But AI agents, I want to talk about that because it seems to be the word on, on everybody's lips this year. If last year was all about customized AI systems, this year is definitely the year of AI agents, I would say. And I find that interesting, not just because I'm a bioethicist and it's pretty obvious that these systems are raising new ethical challenges, but also I'm a medical anthropologist by training. And this moment seems to me like a kind of watershed of sorts in human history, not to over-dramatize too much, but as I'll get to more in my talk, when we talk about AI agents, what we're really talking about is a transfer of knowledge and power over to AI systems. Who are already starting to think for us, and now we're on the horizon of having them do things for us, right? All kinds of things that were normally exclusively under the jurisdiction of human beings, right? And I have to say, while there might be plenty of things to criticize about this transfer of power, I'm really coming at this from a position of, not from a position of critique, but rather one more of kind of anthropological curiosity, if you will. In the sense that if we're going to envision a society and a culture where we're handing kind of the keys over to AI systems, what actually needs to happen, objectively speaking, for things to go well in that kind of scenario? So that's what I'll be talking about. Am I doing a double mic there? Sorry if I am. So that's why I think this moment is, significantly challenging some of our AI ethics as well, some of our assumptions about AI ethics. So there's no real solid definition of agentic AI quite yet, though I'll show you shortly some ones that do exist. But this one here comes from the AI Safety Institute Consortium, which recently formed a working group to come up with a taxonomy of agentic AI tools. And how they defined it was an AI system that autonomously solves tasks rather than just passively responding to prompts. So it doesn't just tell you things, it actually does things, right? And it does so by embedding AI with a particular scaffolding that allows it to manipulate these external tools and perform actions beyond just text output. So it actually reaches out into the world and does something. So this means we're moving from, a kind of static system to systems that perceive and act in the environment and potentially with high autonomy. And this focus on environment is really key here, which, as you can see in some of the other definitions of agentic AI, there's this notable focus on AI's interactions with an environment. So you see that highlighted all over. So this is a distinct change, I think, from earlier definitions of AI that primarily focused on pattern seeking or mimicking human intelligence. There's also a focus in some of them on handling environments that are dynamic and unpredictable, something you didn't really see much in earlier definitions of AI. So how do you tell whether an AI system is agentic or not? Well, experts are saying this isn't really the point to say agentic or not, right? Instead, the point is categorizing them, not categorizing them as one or the other, but kind of along a spectrum of agency. So where agency is something you can maybe dial up or dial down, reflecting how much autonomy or initiative or independent direction the agent has without human intervention. And from an ethics or kind of regulatory perspective, it follows that the higher the autonomy, the greater the need for monitoring and constraints and risk mitigation. And conversely, the lower the autonomy, the more we might be able to just depend on some of the rules that already exist around AI. So most AI agents operate in what you might call assistive mode, still with semi-autonomous behavior. So, with some kind of semi-autonomous behavior like continuous monitoring or auto-identification of patterns. So to get a bit more concrete, you can see here some examples along the spectrum of agentic AI, kind of going from less to more agentic. And so to elaborate, some of these things are like just starting from the assistive side to the more agentic side. Ambient documentation, we all know that really well. I was talking to some medical students in a class this morning, and I asked them to raise their hand who actually has, some exposure to these ambient documentation systems. Every single one of them raised their hand. So that's way more prevalent than I even knew. But these are the scribes you often hear about, so maybe some of you are already using them as well. But tools that perceive audio and they draft text, so that's their agentic component, is drafting text. But the clinicians retain full control over the editing and the signing and adding content and things like that. So they don't really initiate actions or decide anything on their own. That's not their agentic, function, but they can summarize, they can offer suggestions for how to code illnesses, or for what they can suggest what kind of further information we need to collect or generate patient-facing kind of explanations, things like that. So, and most of the companies that are creating these tools explicitly promote the idea that clinicians should really be the ones like finalizing these notes before they enter the record. So there's also a growing suite of agentic tools like Limbic, Listen, Ellipsis. There's a bunch of them now that offer mental health services. So these tools can conduct structured intake conversations. They can score these sessions based on various voice or other kind of response metrics, and all without any kind of clinician prompting, right? So far, their outputs are really only advisory at this stage. So they can suggest triage, they can provide quality feedback, and they can kind of integrate with the patient's treatment trajectory, and they can offer on-demand support in between appointments, but still all the clinical decisions remain with human providers. And their regulatory status is actually, it reflects that limited autonomy, which means they're not heavily regulated at this point. So, and then you also have real-time audio perception and risk prediction to support dispatch decisions. So for example, Cordy, I think, is probably the most well-known one. It runs real-time audio analysis and risk prediction during emergency calls. And so this little, this one. Is it this one? No. Oh, maybe you don't see it there, but is it? Do you see it? Oh yeah, there it is. It's like, did I get the wrong slide? So that little white orb you see can identify cardiac arrest and other emergencies faster than human dispatchers, but the dispatcher still makes that final decision, right? And so this is higher agency than simple kind of scoring because it's continuous, it's real time, it actually interrupts, it can interrupt the operator, so it pushes prompts to the dispatcher, but it doesn't actually execute any decisions on its own. So. And then you've got your class of imaging and signal agents. So this is, Viz AI. Some of you, are any of you using this stuff? I'm sure there's some clinicians in here. Anybody using Viz AI in your practice? No. So that's one of the most common ones for medical imaging for real-time detection and triage. There's ADOC for radiology. There's PAGE for cancer detection. So these systems kind of continuously scan studies or live video to generate alerts and triage lists and detection scores that are integrated into all these clinical workflows, and all without per case prompting. So it does all this in the background. The clinicians don't actually need to ask for a specific patient. It's just scanning everything in the background, and then some things pop up, right? So they act as autonomous kind of watchers in the background, but humans are still the ones to interpret the outputs and decide on the interventions. So I'm running through these just in the interest of time. So there's also some emerging companies that are trying to automate, these more repetitive, kind of high volume administrative tasks that are associated with, clinician burnout and burden, things like that. So Truveta, that's featured here, can autonomously ingest and process and act on large EHR and administrative data streams automatically. So initiating billing and routing and analytic tasks with little to no human oversight. So these are massive, like AI-enabled health data platforms for research and analytics, but the stakes are still pretty low because the tasks are more administrative than clinical. They're not right at the bedside, providing clinical recommendations. So the last category that I find the most interesting, and that was mentioned in the last panel too, this is also an area where AI experts like Sam Altman and Jensen Huang and lots of other folks in the AI space said that we're going to see a lot of advancements in the next couple of years, especially. This is discovery agents. So these are highly agentic, kind of in silico systems from companies like In Silico, nice name, but that can autonomously scan these massive data sets to produce new molecules and rank them for fit for drug discovery, automatically feed high priority candidates into preclinical testing, and then they can actually create those candidates, those candidate molecules as well using generative chemistry AI. And so, of course, we mentioned Alpha 3 in the last presentation, the last panel too, but everybody is probably aware of that by now, but predicts protein structures and interactions with very high accuracy. And that gives researchers the scientific rationales for designing drugs and better understanding these biological pathways. And that could replace years of experimentation with computational inference. So accelerating things drastically. So, and these discovery systems are arguably the most powerful and the most agentic, but they're the least autonomous. So they can kind of reach into these enormous chemical or biological data sets, and they can run simulations, they can plan and iterate and self-correct without human prompting. And they can generate these novel hypotheses thousands of times faster than a human team. And for that reason, they're given the least amount of autonomy by design, because their outputs so far remain kind of gate-kept by these scientific norms and processes. So things like peer review, clinical trial regulations, just to make sure that they always get checked and verified and replicated before they end up affecting humans, right? So these are far from point-of-care agents, but they are some of the most powerful. And so that's sort of the rule of thumb here, that the greater the autonomy, the greater the need to de-risk, right? So, and in the not so distant future, we can also expect these and other types of specialized agents to start acting in concert with one another. So combining their multiple strengths to break down task flows, and then that kind of run in parallel, and they speed everything up. And that enhances, of course, their power and their potential, but also potentially amplifies their risks. So a point that we'll come back to. And so now that we know, AI agents can vary in their agency, what they're actually capable of, right, and their amount of autonomy that we're willing to give them, and that we should be thinking about agents not only in terms of the singular, but also in terms of the plural, with some, agents working together in some capacity. I think it's worth going back to some of the essential assumptions why we're creating these tools to begin with, especially given the risks. What's really the appeal of agentic systems in healthcare? And there's this hope that these systems can help to unburden clinicians and other healthcare professionals by taking over some of that rote work that keeps clinicians from getting really meaningful face time with their patients, right? And AI systems can also potentially fill in for real-world resource constraints. So, for example, if there are gaps in local expertise and kind of like low resource settings, AI agents offer a lot of potential for generating and acting on information in ways that are evidence-based, standardized. They follow certain clinical standards that local clinicians might not be trained in. So this is an image from my clinic I worked at in Mumbai, where there was definitely a lack of expertise. I mean, I can think about 1,000 ways that AI could have helped in that setting, especially given just the lack of trained clinicians and administrative support. And so the other side of this coin is that there's now this near universal consensus that we should keep a human or a clinician in the loop. Everybody has heard that by now. It's ubiquitous, right? When deploying AI in healthcare. So if the past 10 years, maybe 20 years in AI ethics has told us anything, it's really this. Like, given how imperfect and untrustworthy systems are, of course, they have high potential, and et cetera, but we need to make sure that clinicians are involved in evaluating, vetting, and in some cases vetoing any kind of potentially harmful, inaccurate, or otherwise biased AI outputs. So I don't think feelings have really changed about this that much, but as people start really digesting the idea of AI becoming more ubiquitous, which is really just starting to happen this year and last year, I would say, and they start acknowledging the real tolls of clinician burnout. People are talking about that as well more and more. I think people are rightfully wondering, at what point can we actually start letting these systems take over? So, but to do so, of course, in a way that is effective and ethically responsible, right? Because don't we actually expect these systems just to keep on getting better and better? This is something that I presented on last year, actually, at this very conference, I think in this very room. But I tried to make the argument that AI is transforming and improving at a rate that's calling a lot of our assumptions about what constitutes ethical AI into question. So until now, all the recommendations and governance strategies that have focused on the limitations of AI, inherent biases like lack of representation in data sets, inaccuracies, hallucinations, et cetera, right? But arguably, we need to start reframing these to focus on the growing strengths of AI. Including agentic AI systems that are moving towards behaving more and more like we want them to behave. So of course, we're not quite there yet. This is probably my most boring slide. Sorry, I had to put the table up there, but no offense to NIST. But and given AI's imperfections, you can't really blame people for being a little bit freaked out about AI that reaches out into the world, right? I mean, that sounds a bit scary, but because agentic AI is not simply AI with the capacity to do stuff, but surely we can classify agents that way, as the AI Safety Institute Consortium has, according to all their intended actions, right? So there are these perception first systems, there's reasoning systems, there's AI agents for resource management, for running code, for interacting with humans and so on. But I don't think it's really this capacity to do things that's really the biggest cause for concern. I think it's more the uncertainty around their intentionality and the degree to which they're involved in co-shaping goals and actions. More and more they're involved in that co-shaping. Because there's really a difference between achieving a goal and then achieving that same goal in a way that's really values aligned. And there's no guarantee, we haven't figured it out yet, how to actually effectively program our values into AI agents. We're starting to, and this of course is called the value alignment problem, which you all probably know quite well. And there are a bunch of smart people working on this, luckily, to make sure these agents are really nice to us and working in our best interests. And Geoffrey Hinton, who's of course widely considered to be the godfather of modern AI, he famously said that we should be building AI agentic systems with maternal instincts, with the assumption that we're building something that's more powerful than us, that's supposed to be acting in our interest and protecting us in some way. So we want systems to want to protect us with that power. And until we figure this out, the current thinking is that we need to deliberately restrict AI agents until we develop appropriate safeguards and ethical frameworks. And that's a point I partially agree with. But you could also argue the opposite, that we need to find a way to live with and actually use these AI agents effectively, even under conditions of extreme uncertainty now. So as an analogy, right, it probably never occurred to some of our early hominid ancestors to forego using fire just because they didn't fully understand it, right? At some point they decided to relinquish total control because the benefits were just too great. So, maybe this is our fire moment in some respects, but luckily, we already have some pretty good models for how to have a relationship with high-performance technologies under conditions of extreme uncertainty. So we can look at certain domains that are incredibly high risk and deploying some of the most high-tech performance technologies under conditions of extreme uncertainty already. So for example, in maritime navigation, there's a bunch of them, right? I won't go through all of them, but ships rely on autopilots, integrated bridge systems, the kind of ship's nerve center where radar, GPS, engine controls, autopilot, all that stuff comes together that help to plot and adjust routes. And in space flight, spacecraft use autonomous or semi-autonomous systems for altitude control and docking and trajectory corrections and fault management and all kinds of stuff. So especially when there's these communication delays between Earth and space, and when real-time control is impossible, right? Connections with Earth. So in nuclear energy, we've got these computerized reactors that, we've got autonomous safety systems that handle all these critical processes where any error can have really catastrophic consequences. And the same patterns show up in aviation and air traffic management, autonomous vehicles, and industrial robotics for manufacturing, rail systems that control, how train systems go back and forth and avoid hitting each other. And so all these places where the margins for error are very, very, very slim, right? And lots of people's lives are at risk, much like in medicine. And even if, financial algorithmic trading, things like that, where automatic systems make these rapid, high-stakes decisions that can affect national, really global economies, they're still using AI. And in all of these areas, professionals have developed protocols and strategies that carefully calibrate their reliance and trust. So they combine automation with oversight, clear handoff points, robust safety checks, all kinds of stuff. I'll go through some of it in a little bit, but all to ensure that autonomy actually helps to improve performance without undermining safety and accountability. So I thought we could maybe learn something by just going through a few of these. So for starters, most systems have some kind of indicator showing what mode or state the automation is in. This seems really rudimentary, but this still appears. And I think maybe we could think about how to do that in medicine as well. But if you remember that sliding scale of like less to more agentic systems, these are kind of the modes that we're really referring to. So in shipping, there's this autopilot helm, and there's other indicators on the bridge that let operators know that autopilot's on, for example, and that help them know how to position themselves in relation to the system at that point. So, what level of awareness to maintain, what kind of fail-safes to engage. And then other systems in spaceflight, you've got the ISS docking systems, that have manual, semi-auto, auto on the crew displays. And nuclear, you've got these control panels. No, not that one there. Next slide probably. But in aviation, there's flight mode communicators that show, which mode, autopilot versus auto thrust states, and so on. So if you think about the takeaway for AI agents in medicine, maybe we should be implementing these in kinds of dashboards, so that show the state or mode of an AI system, advisory, pending execution, autonomous action, stuff like that. So a kind of notice and disclosure approach to not just to the patients, but to the operators of the AI system. So other high-stakes systems provide an immediate kind of unambiguous way for humans to retake control as well. So in spaceflight, manual thrusting, for example, can override automated docking sequences, much like in a self-driving car. If you start to initiate, driving, it overrides the system and it stops the autopilot. And then you've got things like in nuclear, you've got this scram thing. You can just hit the button and it stops everything. These are like kill switches, right? So you can imagine a one-click kind of pause or cancel on high-stakes recommendations or auto orders, programming in kind of hard stops on certain high-risk orders that detect kind of out-of-range outputs, maybe, like they already kind of do to some degree in radiology, to prevent excessive exposure, or incorrect operations there. And of course, there's a caveat, right? Because if you turn off a system, it doesn't mean that the damage isn't already done. So the cascade of events might continue, even if the machine is shut down. You can imagine the stock market or some catastrophic reaction to the stock market. It has, effects on global economies. Just because you hit the stop button doesn't mean that the cascade doesn't continue. But another approach is to specify conditions where autonomy should apply and then restrict any kind of use of agentic systems outside of those very specific contexts. So in railway systems, they do this already. So semi-autonomous or autonomous train control only applies to certain track segments and signal states that are certified. They actually have a database where you certify these particular places where it's allowed. And likewise, enabling safe driving mode in autonomous cars, that's already limited to mapped roads, certain weather conditions, speed thresholds, and whatnot. And so in medicine, you can imagine that this might mean the use of certain agentic systems that can only be used, maybe with certain validated cohorts or certain data conditions or certain clinical scenarios. In the same way we think about other medical treatments as indicated or contraindicated, we can think about that in terms of, what that might mean for agentic AI. And then just kind of going back to our uneasiness about the intentions of AI agents, I think another compelling feature is to make the AI agents' moves, their next moves, a bit more predictable and even visible in some sense, in the literal sense, actually. So in industrial robotics, there's these systems that shine light rings or other kind of floor projections to show the robot's path so people don't get in the path and get run over. And in aviation, you've got certain autopilot systems that, include flight director cues that show the plan kind of pitch or roll and let people know what's about to happen before it actually happens. In shipping, they have augmented reality in certain circumstances that overlays, on windows for collision avoidance, and they show the projected course. So in medicine, that might look like, a preview of something that's about to happen. I'm thinking, there's all kinds of clever ways that I haven't thought about yet, but AI will schedule this lab in 3 seconds, unless somebody cancels me or something like that. But something that shows what's about to happen that allows clinicians to say, okay, I'm going to stop that if need be. And actually, that's another strategy to optimize our responsible use of these tools. It's assuming that anybody's standing by to actually pay attention and see, what these warnings are about. 10 minutes, okay. So, it's to make sure that operators are engaged and attentive. I think this happens on autonomous cars. There's certain ways to de-risk and make sure that people are actually paying attention, they're engaging in certain ways. So extrapolating to medicine, you can imagine like tracking human engagement and oversight of these systems in various ways. And so, of course, there's a bunch of other strategies. There's not really time here to go through all of them. But the broader point is to kind of leverage what these other domains are doing, these high-stakes domains, and then take some of these lessons learned and apply them to the use of AI agents in medicine. And I'm not sure if you noticed, but in all those examples, hardly any of them are actually giving full control to these autonomous systems. So in most cases, humans are typically always, just initiating the commands and then, or the mission parameters, and then, they cede the execution of that to the agent. So, and even if healthcare ever really granted full autonomy to AI agents, it'd probably be in very narrowly defined situations, where we know that AI is doing demonstrably better than humans with strict guardrails and so on. So, kind of moving beyond those lessons learned from these other industries, another way to improve the responsible use of AI agents is to address some of their major limitations. And so far, AI, apart from maybe LLMs, but even them, are bad at understanding context. So if you look back at those earlier definitions of the environment, of AI agents that focus on the environment, gathering all this information outside of the human-computer interaction, humans still have a really big advantage over AI in the sense that we have all this additional context that AI agents actually don't have. And so, a lot of the knowledge that AI agents need in order to do their work is tied up in us, it's tied up in humans. And so with this in mind, developers are trying to equip agents to go and gather that kind of information so they don't always have to keep asking us for it. So, one of the most developed uses of agentic AI in healthcare is just answering questions from doctors and patients. And so, the system can retrieve facts and generate explanations and even work in teams that provide feedback to one another, but some information, especially some of the nuanced information, those context-specific details still require a lot of input from humans. So maybe we need to be designing AI agents to ask, and kind of like learn from us in clever ways. And then the input for all this stuff doesn't actually have to come just from what we tell it either. So in principle, they could also draw from all kinds of signals or biosensors or sensors of the ambient environment to refine their inferences and actions. So for example, in some of the work we're doing around closed loop deep brain stimulation at Baylor, this is Dr. Samir Sheth. The goal is to adjust stimulation in real time to a person's unique brain activity. And so the challenge is that we don't really fully understand what a lot of these heterogeneous brain signals actually mean. So our teams are trying to use AI to detect brain signals that characterize certain neural activity patterns and trying to use the environment information from the environment to contextualize that and give us an idea of what those neural signatures mean. And so if you consider what really unlocked large language models was the inclusion of these ever greater and larger data sets, which really enabled this really dense appreciation of words over this unfathomable, kind of range of context. And this phenomenon of getting better and better with more data, of course, as you all know, is referred as following scaling laws, right? And of course, the second unlock was reinforcement learning from human feedback, so the question is, can we apply some of these same types of mechanisms to scale up agentic AI so that they're able to understand context by having greater exposure to this ever, more enormous ranges of context? So that can be use case specific at first, but that might eventually result in rich, multimodal, foundation models that let you know that X means Y, or if observed in context Z, and so on, right? So. Another way to facilitate context clues is to start designing hardware in new shapes and forms that allow them to better, get that context. So, and then you don't have to think about context just in terms of what's outside of us, but also maybe what's inside of us, right? So, like in the case of systemic pharmacotherapy, which would advance significantly, with ready access to information on how drugs can circulate through the body, how they're affecting multiple organs, liver, kidney function, things like that. How can we design AI agents that are at least linked to AI agents that can gather this information? So once we kind of untether AI, agentic AI, from its reliance on what humans tell it, then we likewise unleash the potential for these systems to start asking questions that move beyond what we ourselves are capable of asking. I mean, that's the hope, right? So we're all familiar with this adage, good science comes from good research questions. But so far, agentic systems are not really coming up with their own questions at at a level that really surpasses the kinds of questions that we might ask. But it's very likely that we are not asking all of the best questions, right? So if we really want to think beyond our own perspectives, we need to be thinking about designing AI agents that can gather all these, huge variety of data types and reason over them to generate the kinds of questions that we aren't thinking to ask. So I'll have to skip over some of these slides, but there are many people working on this. Multiple agents working together to advance insights that are working in parallel that decreases the kind of time scales that we're talking about. So one of the things that Andrew Ng, he recently made the point that agentic AI is propelling these workflows of all types forward because it can be designed with the capacity for multi-agent collaboration. So that's different agents kind of playing different roles at different places in time. And by engaging these different APIs, planning and reasoning out different steps of the process, then engaging multiple agents in collaboration, the whole workflow can be iterative and non-linear, right? And what he wanted to highlight is that these workflows enable parallelism, where progress is made in parallel rather than kind of sequentially. And that quickens the generation of hypotheses and potentially solutions, right? So then you can prototype a bunch of ideas at once, which is great, but then pick the best ones, from that big bunch. But he pointed out that if we do this, then the bottleneck really becomes evaluation, not generation. But we'd have, of course, so much more to work with, which is a great problem to have, but it would put pressure on companies, and institutions to come up with more kind of more efficient evaluation techniques. But the sad truth is that, coming back to the human kind of evolutionary stuff, but it's evaluation, at least the kind of evaluation that really counts for humans is really slow going. Even if we get compelled to get good and fast at evaluation, human trust is really complicated. And from an anthropological perspective, there's all kinds of evolutionary reasons for this, and without going into the specifics, of course, trust and confidence are really not things that happen on really small time or short time scales, So trust is really likely to be incremental. But giving these systems kind of incrementally more autonomy in stages can help to build these mental models of its behavior. How are we doing on time? Okay. I probably don't have time to, let's see if I can. I do want to mention one really interesting study by Dr. Kostick-Quenet, actually. A really cool example of if we're going to be evaluating, if the bottleneck is really evaluation, we have all these computational kind of modeling techniques to be able to aid in this evaluation. And some of the most interesting work is we're taking AI agents and not really evaluating them one by one, but if we consider that we're going to be employing a lot of these systems at the same time, we need to be evaluating them in tandem as well. So this is a really cool example by Dr. Kostick-Quenet's team here at the Ken Kennedy Institute. So he came up with this clever way to test and evaluate AI agents, not individually, but systemically. So the work was based on this idea that we need to prepare for this reality of multiple agents working in tandem, right? And they might produce these emergent behaviors that go beyond what any kind of single agent was really designed to do. So using computational modeling and simulation, the team built this large-scale agent based on hurricane evacuation and response, which they aptly called Disaster World. Looks very disastrous. To test kind of how these various AI agents interact under conditions of limited information. So they equipped each agent with its own kind of probabilistic goals and beliefs and decision rules, and plus they could think about how other models are thinking about them as well. It's a very complex picture. But what this experiment kind of showed us was that they produced these emergent group level behaviors that couldn't have been predicted at the outset. And so, when you have all these multiple AI agents interacting, you get behaviors that no one really programmed individually, these emergent patterns, these unexpected kind of bottlenecks and cascades of action, things we might not be able to actually effectively predict, but might have serious consequences, right, for patient care, physician liability of healthcare systems, all kinds of stuff, right, clinical workflows. So if we plan to get diagnostic agents and triage agents and scheduling agents and patient-facing agents and all these things kind of working together at once, we can't just test them all individually in isolation. We need to be anticipating and modeling multi-agent dynamics so we can build safeguards and coordination mechanisms before rolling these things out at scale. So last slide. So in summary, there are actually actionable ways to figure out what we want our relationship to agentic AI to be, and to ensure that their actions are predictable and aligned with our goals and our values. So, the answer to our fire moment, if that's what this is, it has to be yes, of course we're going to try it, right? The benefits are just too great. But like these early humans, using fire to cook and harnessing fire, all that stuff didn't happen overnight, I'm sure. It came with rules and rituals and shared responsibility to kind of keep it under control. And the same is likely to be true of harnessing AI agents in healthcare. So that takes the kind of concerted effort to make sure that this transfer of power kind of rolls out the way that we want it to. So thank you very much. I'm sorry that I went over.
Thank you so much. That was wonderful. Time for questions?
Thank you. Excellent presentation, and thank you for sharing all this information. So my question is, how do you see humanoid roles in the healthcare industry?
I think it's really, I think the main thing we need to think about is how we plan to position ourselves as clinicians, as, anybody who's involved in the healthcare system in relation to these types of tools. So if we think that these tools we're designing them to do the things that we don't want to do, that we're trying to transition some of the labor onto these tools, we have to make sure that we're picking and choosing the right scenarios and circumstances for this transfer of power, because there's going to be some scenarios that we want to reserve strictly for human interaction. So I don't think that we're ever going to get to the point, I have no idea, but it seems to me that we'll never get to the point where we're just not going to go to doctors anymore. And so, the idea is to use agentic AI to kind of offload a lot of the burden of the things that we don't want to do. We first have to address what are the things that we want humans to do and what are the things that we want machines to do. So even just deciphering out that, what's the jurisdiction of humans versus machines, I think is a really, it's going to take cultural, ethical, all kinds of, societal sorts of input. So I think that would be the first one. And then assuming that we do finally come up with that distinction that works. Of course, we have to test it, validate it, and all of that to see if that's the kind of distinction that we want to have. I think we have to still figure out how we're going to calibrate our trust in these machines because they're being rolled out so quickly as well. That's one of the issues. We want them to be able to be ready tomorrow, but we don't know how to evaluate them in systematic ways in multiple different scenarios and things like that. So I think, and also, just as one physician trying to calibrate your trust in an agentic system, you need all kinds of information. I wasn't there for your talk, but I know your work quite well. Dr. Sarah Gurka, she has, a lot of scholarship on the kinds of information that we need to know about these systems in order to properly calibrate our trust and reliance on these systems. So, and that's something that we need to advocate for, for developers to give the information, and then to train clinicians as well to demand that information from AI system developers. Yeah.
I think we had a question in the middle.
Oh, sorry.
Okay.
Hi, I'm curious about the infrastructure. Do we have enough infrastructure to support not only agentic workflows, because we need a lot of data center support, and also for the future of healthcare? Do we need to build AI native hospitals for systems like ambient AI and whatnot? Like, do we really have what it takes to keep up with how fast things are moving in that field?
I think the most obvious answer at the moment is no. But I do think that there's a lot of investment at the national level and international level, but definitely national level in AI infrastructure. And you would probably have to talk to the network folks that were on the panel just before me, but no, not yet. I don't think that there's the kind of infrastructure for that in most healthcare systems at the moment. But there's a lot of interest, and the motivation is there. So I can imagine it's only a matter of time. I think it's all about demonstrating some value, and if the hospitals are going to see that, and then you can demonstrate value at the patient level as well, then it's just a matter of logic that the infrastructure is going to be built out. I could be wrong, but.
So you spoke a lot about sort of controls on the output and how we act on it, how we interpret that. To me, the much bigger concern is on the input, and it's the design question. You mentioned designing maternal systems. Whose job is it to make sure that the decision-making systems going forward are not based on the iniquities of today's healthcare system, which is, access, outcomes, everything is totally unequal. If we just trained an agent on today's healthcare system, that would propagate, not get better. So how do we think about designing fair systems, designing equitable systems?
Yeah, I come out with the hard ones, huh? I bet I don't know the answer to, but I think that there are certain things that we all can be doing. So I think it's recognized that a lot of the data sets that AI is operating on right now are not fully representational. So there's a lot of effort to making them representational. So through synthetic data or collecting more data, there's also clinical trials that are going on that are trying to be more inclusive. So, they're structured in ways that are decentralized, for example, that can doesn't require somebody coming into the clinic, to gather data that way. So you can do it through telehealth or something like that. So I think there's a lot of recognition of this problem. I think some of the development of our AI systems up until now have been plagued by bias. And I think that we're not rid of that problem at all by any means. But I think we've recognized the problem in a way that allows us to take these strategic steps towards ameliorating it in certain ways going forward. So that's the ideal. I don't know if any of that will. I mean, it's all based on incentives too, right?
There's a question in the back.
Hi, I'm an AI researcher focusing on mental and behavioral health. And while we are deploying these API models running on our patients' records, especially notes, we notice there are content filters that limits that what are harmful, what are risky things to be generated as output in general, right? But since we're the creators, or we can deploy into the, very mechanism level, so we can turn them off or define our own version of content filter that allows certain risk to be generated. So I would like to get your thoughts or opinions. Like down the line, the multi-agent systems are probably have maybe different contents filters, or
Content future, can you just
content
define
filters are like, for example, I deal with patient record with high suicidal risks. And normally, if you ask ChatGPTs or anything about how to self-harm, you will not get an answer. But we need to process these notes, these data to get a certain level of insights of what kind of ideation level, what risk are they facing, so we need to process. So the out-of-box model shouldn't stop us inside their framework. So we'll be able to turn these off. So I assume down the line, more and more sophisticated systems will be able to customize all of these at different levels. So, but once things getting more complex, right? Each model can have their own ethics standards. When they work together, like human us, we have hopefully have a great agreed upon version of ethics, but maybe some have different views. So when these come together in a mesh of working together agents, who have the authorities, or how do we maintain this ethics or the content filters built into it?
I think I know what you're asking. How do you get different disparate sources of information with different inputs, different sorts of assumptions, different priors, different maybe missions or execution goals or something like that to work together? I don't know the answer to that kind of stuff. You really have to ask one of our computational specialists. But from a kind of abstract level, it seems like they all need to be unified under a single goal, a shared goal, a recognition of something, a shared goal, that they each have a clear role distribution in much the same way the military does or the government does or something like that, where the task distribution is clearly defined. That's all I can think of off the top of my head. But it sounds like you know this topic more than me. I'm not sure. You might have an answer already in your mind, but yes.
I was just wondering if you can speak a little bit to the generational change that happens with the trust of these models. I'm thinking of the people that have been in development for this, but then the people that are also growing up in this world, and the trust that may change, and there may be a shift as they really are the ones starting to take over and use it and create it versus the ones that have been designing it in the past.
Yeah, it's a very good question. Very cultural, sociocultural, aware question. But I mean, you said it, right? So the trust of younger generations is going to be probably different than that of older generations. The questioning and maybe critical thinking is something that I think younger generations are fully capable of, and they are doing much more than we think they are. And they're using AI in ways that I think are they're astounded. They would astound all of the older generation folks like me who think that we need to train everybody to use it responsibly and ethically and things. But I think younger generations are already using it in such creative and very ethically aware ways as well. I mean, I can't speak for everybody, but so I would say for the older generations, I wouldn't underestimate the younger generations. And for the younger generations, obviously, you want to cultivate that critical thinking constantly because there is a greater acceptance. There's just a greater fluency, and everything like that. So that's going to help the younger generations, but I think that they do need to be equipped with a little bit more skepticism, maybe than they currently have. But.
Yeah, one last question.
Just a comment, follow-up on the question the gentleman asked. Actually, ChatGPT will give you, that's the ethical question, where is the highest bridge to commit a suicide? It'll actually give you the name of the bridge and the directions. So that's the ethical question that we need to answer, how to direct this in a meaningful way.
I mean, this is a problem when you create, AI systems that are intended to do everything. They're general purpose systems. If you want to have the highest bridge, it's going to give you the highest bridge. If you're going to use that for the purposes that are personally relevant for you, so you can't design an AI system that's generally applicable that's going to not tell anybody the name of the highest bridge around them, So unfortunately, I don't know the answer to that kind of like those guardrails. I do know that they're thinking about this really hard right now. There's obviously a lot of coverage in the New York Times most recently, right? So I can only think that companies like OpenAI, I mean, Sam Altman has had tons and tons of coverage on, YouTube, and there's tons of videos of him talking about this, and also Anthropic, Gemini. So people are definitely thinking about how to do this, but it's really hard when you have these systems that are supposed to do everything. People are really, their goal is to really develop artificial general intelligence, and they're well on the way to doing that, it seems like. And I don't think that we should just say, oh, well, this is the collateral damage of that. I don't think that's the best approach at all. So I don't know what the best approach is, but I'm hoping there's some really smart people working on that kind of stuff. But my thinking is that, the folks who are looking for, something like support, like emotional, social support, some psychiatric support, if there were a tool other than ChatGPT that they had free access to, like they have free access more or less to ChatGPT, then they could go there and they would know that that was trained on, data sets of between clinician and, interactions between clinicians and patients and stuff that was a lot more relevant and a lot more safeguarded. Who knows, some people might use the one that's not safeguarded by preference, but at least if that were available, I think making these like narrowly defined systems more available is at least one potential solution. So.
All right, let's thank our speaker. Let's present.
Thank you all for the good questions.